Okay, so today we are going to start some more application of dot product. So again, let's go back to the triangle now. If we have two vectors A and B, and if the angle between the vector is theta, what triangle law says? The resultant of these two vectors will be the line joining the tail of the first to tip of the second, and we call this as R vector. And as per the definition of triangle law, we can write R vector equals to how much? A vector plus B vector. And we know the resultant modulus. How to find the modulus? We have a formula. Under root of, tell me guys, what is the answer?
A square plus B square.
A square plus B square
plus AB cos theta.
Plus
plus
AB
AB.
cos
AB or
cos
2AB?
theta. 2AB cos theta.
2AB cos theta. And this is what we derived using the Pythagoras. So we completed the right angle triangle, if you remember. And after completing the triangle, we use the component. So we said this is B cos theta in length. And we said this is B sin theta in length using basic trigonometry. And then we use the property of Pythagoras to get the length of the resultant, which is the magnitude of the resultant. So now the question is, can we derive it easier way, like without doing all these things? And the answer is surprisingly yes, we can do it. So R vector is A plus B. So what if I take the dot of R with R itself? So this is like writing A plus B dot with A plus B. And now you can see the LHS is nothing but the R square. Because the two vectors, if are equal, it means the angle is 0. And by definition, A dot A is how much? A square. So R dot R will be R square. Is this part clear?
Yes, sir.
And then we can keep on doing the multiplication by taking the dot. So the first term is A dot A. What this will give you? A square. Then A dot B. A dot B plus B dot A. It's a repetition. I can put it twice. The last is B dot B. So you can see clearly that R square turns out to be A square plus B square plus twice of A dot B. And by definition, you can write A dot B as AB cos theta. Correct? And now you can see the R, we got the answer without using the Pythagoras. So the dot product is a really powerful method to get the magnitude relation. Okay. Is this part clear? Now we can use it for some more purpose. Let's say the alpha is the angle between R vector and A vector. So how to get alpha? So alpha is angle between A and R. So we know R is given by A plus B. So what is the value of R dot A? A plus B dot R, so dot A. So I'm just writing R dot A as A plus B dot A. And why I took the dot with A? Because I want to know the angle between R and A. Now we are going to use the definition of dot product. What is R dot A? R A cos of angle between R and A, and that is alpha. Now A dot A will be what? Tell me guys. Expand the bracket, what we can write?
A square.
And then B dot A becomes AB cos theta. And you can clearly see one A will cancel out because that's common. And I got the cos alpha is A plus B cos theta upon the length of the resultant, the magnitude of the resultant. And you can also see in this triangle, this we could have written directly, right? You can see cos alpha is base upon hypotenuse, and base is A plus B cos theta upon R. So these are the ways in which you can get the answer. And dot product is used in a way to prove multiple things. Dot product is not only meant for physics. Many advanced concepts of mathematics can be solved using dot product. So we can solve some question of maxima and minima. So the maxima and minima I will teach you in mathematics. And we'll see how we can solve. So let's say if I give you a 2a plus b plus 3c equals to, let's say, 12. So we have a, b, c some magnitude, and that is equal to 12. A, b, c are some numbers. So find the maximum value of a square plus b square plus c square. Now, when you look at this problem for the first time, you will get no idea what is happening and how this is anywhere related to the dot product. So it's very difficult to understand the relation as of now, but very soon you will see the relation. So let me tell you, show you the dot product in multiple ways. The way of looking at it in physics, in mathematics. So you must have heard about the quadratic equations. And how we write? Ax square plus bx plus c equals to 0. Okay. And you can see every term is the product of two terms, ax square, bx, and c into 1. Let's say nothing is there, we can write as 1. So ax square, bx, and 1. We can write like this. And the entire term we can write as ai cap, bj cap, ck cap multiplied by, or you can say take dot x square I cap, x j cap, and k cap. And you can see both are same thing. Yes or no? Can you see? So if you know the dot product, the I will go with I, j with j, and k with k. So we can remove the coefficients as a one vector, and we can treat the remaining variable as another vector. And this is how we can express the above equation. Is this clear? Yes or no? Does it make sense? Guys, tell me.
Yes, sir.
And now
Yes, sir.
you can think this as two separate vectors. Then how to write the definition? What is the A dot B? Mod of A into mod of B into cos theta. Can be write like this. And you can see this is nothing but under root of a square plus b square plus c square. And this is under root of x power 4 x square plus 1 into cos theta. Okay. So now this is a unique way of writing the any equation. In fact, any expression, algebraic expression, any polynomial degree equation, let's say if I write a naught plus a1 x square plus a2 x cube plus dot dot, we can write this as a naught I cap plus a1 Okay, now this is too much. We cannot go beyond 3. I mean, that's our dimension. But this is basically kind of dot product in dimension. I mean, of course, this is something you are not heard of. So this is called n-dimensional dot product because we have n different terms. I think n plus 1. We have n plus 1 dimension. Okay, so here we have 3 dimension, but here we have n plus 1 dimension. And now this higher dimension things are not part of JEE syllabus. You will learn about all these things later on. But this is actually written in this fashion: A0, A1, A2. Now, when we exceed the dimension, the vector notation is insufficient to write. And therefore, we came across a new way of writing this, and that is called matrices. So this is called the product of two matrices, and the matrices can be written for any dimension, and that is the beauty of creating this new mathematics called matrices, which is also part of vector only, but it is taught in algebra as a separate topic called matrices. Vector is also called algebra. We call it vector algebra, which is again part of a bigger chapter called linear algebra. But of course, those things are not required. Now, this is some idea like how the world sees the mathematical equation and how you see the mathematical equation. So every polynomial equation of any degree will represent a dot product. So if you have 3 terms, it is IJK 3 dimension, and if it is more, then it will have more dimension. So anyway, coming to the basic definition that we have. So what I gave you, 2a plus b plus 3c. 2a. So our question was 2a plus b plus 3c equals to 12. So can we write this as 2i plus j plus 3k dot ai plus bj plus ck equals to 12? Can we write like this, guys? Tell me, yes or no? So can we convert this into this format? Not very intuitive, but we can write like this. And now, once we have written in this format, we can write the definition of a dot b. So you can treat this entire term as capital A and this entire term as capital B. So it looks like a dot b is 12, which you can write as ab cos theta equals 12. So cos theta is how much? 12 upon ab. And we know from the trigonometry that cos theta is always less than or equals to 1, right? Which means product of a and b cannot exceed 12. I can just rearrange the terms. So what is a representing? A is the modulus of the vector a, and this will become 4 plus 1 plus 9. How much is this? Root 14. And what is b? Which is a square plus b square plus c square. And now the product is how much? The product is less than or equals to 12. Squaring both sides, 14 into.
Sir, it should be AB is greater than equal to 12.
AB, yeah, it's AB is greater, it's coming greater, no? Yeah, right. This is the change happening. So this is, yeah, I made a mistake. This is more than. more than equals to, more than equals to. So we'll get a minima actually, the minimum value. So a square plus b square plus c square, I will change the problem, is 144 upon 40, which equals to how much? We can divide 72. So, okay, so here we are getting more than equals to this value, which means the minimum will be how much? Because the value is more than equals to this value. So the least I can get is 72 by 7. So I will change the problem. So find the minimum will come here. So the minimum we can get is this much. Okay. So this was the question from maximum minimum. Again, this is the question from mathematics. Nothing to do with the physics. So any doubt in this, guys?
Yes, sir.
You have doubt?
Here.
So of course, this is not very easy. But as you go in mathematics, these things will help you. Not now. So now it is of no use. Only if you learn maths, maxima, minima, and all those things, you will find it's really useful. So we'll see now some direct application in physics. And this is like some awareness scheme actually. So I will try to show you the entire physics wherever the dot is applied or used. And all those things will not be very conducive to you as of now. You may find it very difficult, very weird. Just bear with me for some time. It is only uh, the purpose is to acquaint you with the various terminology that you will come across in physics. So the first definition is called work done by a force. So I have given you the example in the last lecture that if you kick your friend, what will happen? Your friend will move faster. And because your friend will move faster, can we say the friend will have more kinetic energy than before? Yes or no?
Yes, sir.
And if your friend is having more kinetic energy, from where he received that extra energy? So the answer is the kick. The kick did the magic. Okay. So force and displacement are vector quantities, but when they come together, they create an effect which we call energy or work. Okay. So later on, we will learn in the chapter of work, energy, and power that work is a method by which energy can be exchanged between two bodies or system. So work is a way of exchange of energy. So when you kick your friend, you make sure that now some energy can be transferred. Understood? So work is a method of energy transfer. And that is the whole idea of work done in entire physics. So whenever someone is doing work, then someone is either taking the energy from you or giving energy to you. And how we understand whether it is taken or given? It's a very simple. When you do a positive work, so let's say that the mathematical definition is giving some positive answer. It means the force has given the energy to the system. And if the work done by a force is negative, it means we have extracted the energy from the system. So you can take a simple example. if you throw a ball vertically upward, what you see? Will it slow down or speed up?
Slow down.
So the energy which you gave to the ball in the very beginning, someone must be extracting away from the ball. Yes or no?
Yes.
So can you guess which force is taking away the energy?
Gravity.
Exactly. So it is the gravity which is taking away the energy from ball actually. So eventually ball will stop somewhere. Yes or no?
Yes.
It means all of the energy given in the very beginning is taken away now, right? That's why there is no energy to move forward, and therefore the ball will stop. And after that, what will happen? Will it come down or remain there only?
It will come down.
So it will speed up or slow down.
Speed up.
So now gravity is giving back the energy. Yes or no?
Yes.
So you can see while going up, the gravity was doing what, which kind of work? Positive work or negative work? So while going
Negative.
up, the gravity was doing negative work, but while coming down, the same gravity is doing positive work. Yes or no?
Yes, sir.
So gravity is doing positive and negative work, and it depends on the direction of motion. Okay. So now the question is how to relate these two things or these two ideas in dot product application. So the definition of work by our syllabus talks about the constant force. If the force remains same, if the force is not changing, then the work done will be how much? The force dot with displacement. And how we represent the displacement? The symbol delta and r. What is r? If you remember, what is r? R is called the position vector, and delta r is called
Change in position.
change in position vector. Very good. So if someone will ask you define displacement, how you are going to define? Define displacement. How you are going to define?
The minimum change in position vector over a certain period of time.
So there is nothing like minimum.
Yeah.
It is simply change in position vector. Okay. Because the displacement is a vector, so definition must be vector. So what we write? Displacement. Let me define that displacement vector here. So the symbol is logical delta r because we don't have any symbol. Is it correct to say displacement is the minimum separation between 2 points? Is it correct to say? Shortest distance between 2 points is called displacement. Am I right to say this?
Yes.
Anybody else who think this is correct? Displacement is shortest distance between 2 points. Is the right answer or wrong answer? Okay, so I think Rugved has said yes, it's the right answer. So tell me, displacement is vector or scalar? What is the displacement, vector or scalar?
Vector.
And the shortest distance is what?
Scalar.
So how a vector can be equal to a scalar? Now that's contradiction. So the definition is inaccurate. Now in high school, you never studied displacement. What you studied was the magnitude of displacement. So now you're going to learn the displacement for the first time. So in class 9th, when we study kinematics, we actually don't study displacement. We only study the magnitude of displacement, and what you said is called magnitude of displacement. The shortest distance is the magnitude, but not the vector. So let's say you were at point 1. Let me remove the word. So a person was at point 1 in the very beginning, and then we choose some random path to reach at another point. I'll say 1 dash because the same particle has come here. And the observer, when we look again, let's say the observer saw you at 1, then he slept for some time, you ran in a jungle and then came to 1 dash. Okay. So now the 1 dash is a new location that the observer will watch you, and the new position vector is representing your new location. So this is called the initial location, Ri, or initial position vector. This is called the final position vector. So it seems like you got displaced from here to here. So displacement is a vector which always points towards the final destination from the initial destination. So you were at 1 and now you are at 1 dash, and therefore the line joining these 2 points with the proper arrow represents the delta R vector. And again you can see it's a triangle. So using the triangle law, can we relate these terminologies or these terms? So what we can write here using triangle law? Tell me guys, anyone?
RF is equal to Ri plus delta R.
Excellent. So you had some initial position, and then you suffered the displacement, and this changed the value to a new value which we call R final. So initial plus the change is the final, and therefore we can also write change equals to final minus initial, and that is what the definition comes from. Displacement is defined as change in position vector. You can see change. So it is defined as change in position vector, and of course these things are not possible to be taught at elementary school level. So whatever you learned there is okay. You haven't done something wrong, but something incomplete, I would say. And not only you, we all have learned the same thing. Is this clear?
Yes, sir.
Yes.
Now given the coordinate, let's say if I say the location 1 is having coordinate x1, y1, z1, and the new location is having the coordinate x2, y2, z2, then we may express this answer in terms of analytic form, that is the I cap, j cap, and k cap. So the R final we can write as x2 I cap. I'll give you simple way of writing. We can write x2 comma y2 comma z minus x1 comma y1 comma z1, and then you can subtract the ordered pairs one by one. So you can write x2 minus x1 comma y2 minus y1 comma z2 minus z1, some big bracket. And then if you wish, you can write in terms of ijk. Eventually you can express as x2 minus x1 I cap, y2 minus y1 j cap and z2 minus z1 k cap. And the question is simple: how to find the magnitude? So what will be the mod of delta r? So because delta r we got as the change in x coordinate I cap, change in y coordinate j cap, and change in z coordinate k cap. So mod of delta r will be, tell me guys,
Of
what we
x2
should write?
minus x1 square plus y2 minus y1 square plus z2 minus z1 square.
Excellent. So we can find the modulus. And whenever you need a modulus, you can take the dot with itself, delta r dot delta r, you get the same answer. So now this is how to find the displacement modulus. So this is what you learned earlier. And this is nothing but the distance formula, if you remember. So distance formula in maths refers to what? The shortest distance, not the actual distance, isn't it? Because distance is something which depends on the path taken. But in maths, we understand distance formula in a different way. We always think as a line joining the two coordinates. That's called the distance formula. In physics, distance is a difficult topic. It is the actual length of path which you traverse is called distance. So don't get confused with the word distance formula and the reality that is called distance. Okay? So not to be confused. These are two different things. And if the force is constant, the work we define as. So work is always defined for a given force. And if the force is constant, we write F dot delta R, and therefore the F dot delta R we can rewrite in terms of component also. So can we write F as Fx I cap, Fy j cap, and Fz k cap? Yes, we can write in component form. Dot, and delta R we know is x2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. And from the property of dot, we know how to write this. I will go with I only. So fx into x displacement, fy into y displacement, and fz into z displacement. So this is the final formula. You can also write in terms of component. It depends on what is given to you. So after knowing all these things, we can do some practice. So let's say the force is acting in space by the and is expressed in terms of 2 I cap plus j cap minus 3 k cap, and you go from point A 1 comma 1 comma minus 1 to a point B with coordinate 3 comma minus 1 comma 2. Find work done by force F. So tell me the simple answer. I'm giving you 2 minutes to solve. This is more than enough. So what is the answer, guys? Tell me.
So 4 I cap minus 2 j cap minus 9 j.
So root 17.
Okay. The first step should be find the delta. What is delta, guys? Final minus initial. So 3 minus 1 is how much? 2, comma. Minus 1 minus 1. Minus 2. 2 minus minus 1. So how many of you are getting this delta first of all? Very good.
Sir, I got it.
So now the work done by the F is what? It's very simple. F dot. So now once you have the delta in terms of ijk, so 2i plus j minus 3k dot 2i minus 2j plus 3k. And how we write dot? I will go with I. So 2 2s are 4. 1 minus 2 is minus 2. And minus 3 is minus 9. So how much is the answer? Minus 7. Or you can say if it is Newton, so we don't know the units. I will write just here. So if it is in meter and in Newton, then the answer becomes joule. Right now we can just write unit. We don't know which unit we are trying to solve. It is clear, guys?
Yes.
Yes, sir.
Yes, sir.
Anyone who got this answer? Like
There's
minus
some
7?
calculation error in the last step, but the procedure is the same.
Yeah, great. So what we can do next is yes.
So,
Tell me. Who is trying to say something? Okay. Anyway. So you have to just find the dot product. Let's do some more practice. Now sometimes you need to do the same thing with your visualization. So sometimes things will not be explicit as we have seen earlier. So let's say we have XY plane. A force is always acting. A force is always acting at 45 degree. And the magnitude of force is 10 Newton, let's say. And this force is taking a particle from let's say 2, 0 to a point in the same plane, which is 4, 2. So this is the final destination. This is initial. And the force is, I haven't shown how it is acting, just the force is acting at 45 degrees with horizontal. And the body is going along this force or due to this force. So the question is, find the work done by force F. That's it.
So I had a doubt in the
Yeah, tell me.
dot product gives us a scalar quantity. How will that work vector quantity?
You can see the last answer we have numbers. Fx is a number. So we don't have I and j and k, right? I dot I is what? 1. J dot j is 1. K dot k is 1. And I dot j, I dot k is 0. We have done this, right? So the moment you take a dot, you will get a number, isn't it? Numbers
Okay.
means some scalar. You get some scalar. Are you getting this idea? What we are discussing here? The dot will give you some scalar, isn't it?
So
I think your dot is not clear. Huh? What is your confusion? Tell me what is your confusion? Force is a vector, delta r, which is a displacement, is a vector. The dot will give you scalar, isn't it? And here we don't use AB cos theta. Why? Because when vectors are written in terms of component, we can directly take the dot because we know the dot of I with I, j with j, and k with k, and all this. So in dot, what we do? We multiply x component together, y together, z together, and we add them. Of course, with sign, plus, minus, and so on. Okay.
yes.
So this question is clear. How we got -7? No, this is the problem number 2. So what is the work done here? So first of all, you need to express force in component form. So what is the F vector, guys? How to write a F vector? We know how to resolve a force, resolve a vector into components. So what we can write component wise? What is F vector?
That would be f cos theta I cap plus f sin theta j cap
Correct. So the theta here is how much?
45. So by root 2.
By root. Very good. So this will be
10 by root 2 I cap plus 10 by root 2 j cap.
10 by root 2 I cap and 10 by root 2 j second I plus j. Correct. So the force we got is 10 by sorry 10 by root 2 I plus j. Now given the point, can we find the displacement, guys? Yes or no?
Yes, sir.
So 4 minus 2 is 2 I cap. Am I right? And 2 minus 0 is 2 j cap. So can we write like this? And therefore, the work done by the F will be how much? F dot delta. So 10 by root 2 I plus j cap, and 2 is a number I can multiply separately. Dot. This is 20 by root 2. And I dot I is 1, j dot j is 1. So we get 1 plus 1. So how much we got the answer? 40 by root 2, which is 20 root 2. Let's say this is joule now. It is in meters. Is this clear, guys? Why it is the answer? This is not very difficult. Or is it difficult? I mean, are you finding this difficult?
No, sir.
All right. So the third way of asking the same question is like this. A force of value 12 Newton is acting in the direction parallel to, I mean, of course, like parallel to this unknown vector 2y plus j plus k. So force of value, this is acting in the direction parallel to this vector. Displaces a particle from 1 comma 0 comma 1 to 2 comma minus 1 0. Find the work done. Let's say this is in meter. So find the work done by force F. So now it's again a question in which we have to convert the force. We have to express the force in vector form, and the problem is the force is not given in vector form. So we cannot take the dot until we have vector notation. So you have to use the idea of something which we have discussed. So can you try this question now? Anyone interested in solving this question? I think no one is interested. Huh?
Yes, sir. Sir, give me 2 more.
So me too.
Great.
Done, sir.
Okay, so you got 0 answer. Okay, it's coming 0. Interesting. Maybe that's quite possible. So what is the delta R here? Always, first of all, find the delta R. I want everyone to tell me the delta R before you solve. So tell me. Okay, Rugved will tell me. What is delta R, Rugved?
J cap
J cap. There is no I cap.
and minus 1. No, x minus 1 I cap
So I cap,
minus j cap
J cap.
plus k cap.
Are you sure?
Yes, no, minus k cap.
Yes, yeah, right. So the delta R we got. Great. And so the answer is going to be 0 for sure. But anyway, anyway, luckily the answer is going to be 0. But can you tell me what is the F vector? If you
2i
remember
plus
the, yeah,
2i plus j plus k.
2y plus j plus k is the F vector. Are you sure?
Yes, sir, because they are parallel.
So how they're equal? If something is parallel, then will it be equal? When two vectors are parallel, what must be equal? That's the
The
takeaway.
direction. Yes.
So now comes the real concept of vector. If we have two vectors, and this is something we are going to use a lot in physics. If two vectors are parallel, what must be equal?
Directions.
Anything else?
Magnitude as well.
No. How you can see the lengths are different. They are only parallel. They are not equal for sure. I mean, they may be, but we cannot say with surety that they are equal. So if two vectors are parallel, what must be equal? Now
So
this
they are
is the
unit
tricky
vector.
part. Yeah, now you remember. Very good. So this is again revise. You must not forget this. If two vectors, we have done this explicit. If two vectors are like parallel, then their unit vectors must the unit vector must be equal, right? Because a unit vector is what? The length is 1. So A upon mod of A will have same direction and same magnitude as B upon mod of B. Yes or no? Tell
Yes,
me,
sir.
guys. So can we write F vector upon its modulus, which is given to us how much? 12. So can we write F upon 12? The force vector upon its modulus must be equal to the unknown vector. I think what is the unknown vector? Upon its modulus, because these two are given parallel to each other. Yes or no? And this will give you the idea how to express the answer in vector form when this is given. So 2i plus j plus k is how much? If you take the modulus, under root of, correct?
Yes, sir.
So this will be 2 root 6 into the entire term. So this is the answer. Now because we know f vector now and we know the delta, so work done is how much? F dot delta, and we got a very nice vector notation of f vector. And the delta we got is I minus j minus k. 2 root 6 will do nothing. Then 2 into 1 is 2. 1 into minus 1 minus 1. 1 into minus 1 is minus 1. Oh, luckily this is 0. Okay. So you understood the method how to solve question like this.
Yes, sir.
So now comes the, I don't know which problem number. The very famous cube problem. We always solve, right? Okay. So let me assume some value. So this is, let's say that this is 3. The height as 4 and the length is 5. You can take meters. Okay. So a particle goes from O to A. Now, in the definition of work done, does it matter the path taken by the object? Displacement depends on path, yes or no?
So it depends on the position vector. So path could be anything.
Yeah, so it depends on the
Yes, sir. Part
initial
that.
and the final, right? It has nothing to do with the path. That's correct.
Yes, sir.
So imagine there is a force acting parallel to this vector. Okay. And the magnitude of force is the magnitude of force is, let's say, 10 meter, acting in the direction as shown in the figure. Okay. So a particle goes from O to C. This is what I like. So a particle goes from O to C under the action of constant force F acting parallel to line OA. Okay, that's how I can express the question. Find the work done by the force on the particle. So you can take 5 minutes, think about it, be relaxed, don't worry. Choose the proper coordinate system as you deem fit. Choose the proper axis XYZ as you deem fit. Write the coordinates properly and then tell me the answer. I hope I'm okay. I'm clear. Question is clear, guys? Yes or no? Now, this is definitely a challenging problem. I'll put a 3-star rating. So if you solve this question, then I will raise the level. Else, I will keep the level same. So I will not give you a difficult question than this. So 5 minutes to everyone. See, in vector, you're not learning only vector, you're learning the entire physics. If you can play with my idea of vector, the entire physics will appear nothing to you, just like a joke. Someone's network is not working today. Since of network is not working. $50 joules. Okay, let me check. I'll wait for some more time. Everyone else should respond. 41, nothing modification. All right. Again, in when you calculate vector, why how you get k cap something? So in calculation of work, then it should be some number, right? Dot never gives vector answer, right? Okay, so 82 by root 2 joule. Oh my God, something more dangerous answer. But possible. So let me help you guys. So what I'll do is I'll redraw the cube here, the cube word, sorry. So I think we have done some cube problem in the very beginning, right? When we were learning the position vector. So now we confirm. Yeah? So the first step is take proper coordinate system. So I'm taking x, y, z like this. So I will take this O as the origin, y axis. So tell me guys, what is OC vector? And I have told you how to get the OC vector. Walk from O to C along any side. And keep on writing the I, J, K. So the length is going 3, 5. So to go to O to C, we can move like this and like this. Correct?
Yes, sir.
So OC vector is the displacement vector in this case. And then can I write this as 5i cap plus 4j cap? Tell me, that does it make sense? Yes or no? Everyone.
Yes, sir.
Rugved are getting it? Shreya, Tanishi are getting it?
Yeah.
Great. So now having this displacement, the next step is finding the force vector. And it is given that the force vector is parallel to this line. So first of all, I need to find the OA vector. Who will tell me OA vector? Anyone?
Sir, can I say?
Please tell me OA vector.
So may I?
Yes, please. Go ahead.
That would be 5i cap
Right?
plus 4j cap
Yes.
plus 3k cap.
Correct. Now force is parallel to vector OA. It is not equal. So what is the next step we do? The ratio, the unit vector must be equal. That's the first step. So again, see, we have to use the relation. The mod of the f vector upon mod of f must be equals to OA vector upon mod of OA vector. As I said, the idea of a unit vector is very, very important in physics or in mathematics as well. So now this will help you in getting the F vector. So what is F vector? F is a number which is given in the question. I think 10 is given, right?
Yes, sir.
So, okay, so I can just write F into OA, the vector form upon mod of OA, the value. So the F vector we can write as 10 multiplied by the OA is 5i. And what is its modulus? Root 50,
Yes, sir.
which is
5 root 2.
5 root 2, but we'll keep it later on. So this is 5 root 2, 10 upon 5 root 2 is a nice answer. It is root 2 times, correct? So you can see that the F vector we got. We got the F vector, we got the delta vector. Now that next step is pretty simple. It's straightforward. Can you take the dot, guys? Can you take the dot and tell me the answer? So what is the answer?
Sir, 41 root 2.
So 5i cap plus 4j cap plus 3k cap dot 5i plus 4j. There is no k. So if nothing is there, you cannot 0k cap, just for your idea. Now you can get the answer. So I with I will give you 25 and j will give you 16. K will give you 0 answer. So answer is 41 root 2 joule. I think this was your answer, right?
Yes, sir.
The last answer. Yes, that's correct. Okay, so now you have realized how to attempt questions like this. They are not very easy, but if you understand the concept of vector, no, this is pretty easy. So these are challenging questions, to be very honest. These are not very easy. Thinking about the unit vector, converting a number into vector formula, and then taking the dot is a rigorous job. It needs some practice. And therefore, before I end this work calculation, I'll give one more question, or maybe the last question for you guys to attempt one more time. Okay. So you see how the questions are created in maths or physics. We can create question. So imagine you are living in a room which is having cubicle shape. Okay. A cubicle room of side length A. Now A is a number. If you get confused, having an insect. Sitting at the midpoint of any edge. So you can think of a cube and the insect is where? At a midpoint of any edge, because all edges are symmetrical. So it's anywhere, I don't know where. Okay. So let's say we have some sort of a fan. The fan is creating the air thrust, which is creating the force. So a force a constant force F. Now F is the value because I'm not giving any number like 10, 12 now. F is the number. So a constant force F is acting along the along the direction of biggest diagonal of Q. You know what it means actually. It means the body diagonal, the biggest side. So constant force F is acting along the direction of biggest diagonal of the cube, which moves the, or we can say that insect moves like this, like this. Okay. If the insect moves from its initial position to the initial position, initial to the nearest corner. Yeah, that's fine. Just yeah. So if the insect moves from its initial position to the nearest corner of the cube, uh, then find the magnitude of work done by the force moment. So it looks interesting question. And see, I haven't drawn any diagram. So it is up to you to draw the diagram, create some vector, assume some axis, and get it done. Okay. All right. So anyone interested in solving this question?
Yes, sir.
Go ahead. F by 6 units. Okay. Okay, so I think I should give the solution now. So first of all, draw the cube. So once you draw the cube, you will get clarity what is happening, how to get the answer. So where is my insect? Okay, it could be maybe many possible answers. Insect can be here, maybe here. There are 12 choices for the insect. And how is my force acting? So maybe answer may vary. So you may get different answer also. So force is acting like this. And the insect is moving from the any edge to the nearest corner, right? So there are two possible answers, I think, and both answers will be correct. You can draw any diagram. It may be here. So it may go from here to here. It may go from here to here, this corner. Okay, so to make the answer simple answer, let's take this example. So this is the initial, and so everyone solve for this. So the insect is here and going towards this location. Solve this question because everyone will get different answer maybe. Now this is easy. Oh, I think it's too difficult. No? Is it very difficult, guys? Okay, I should not create question now. Tell me, guys, if you're finding it too difficult, just let me know. Hello, hello, hello. Rugved, Shreya, Siddhant. Is it too difficult?
No, sir.
Okay. So first of all, how to write the force vector, if you remember? Because all side having a length, we can write the F vector as F upon F equals to AI plus J plus K upon root 3A. So we know the answer is the F vector must be equals to F into I plus J plus K into upon root 3. And what about the delta? Anybody? Delta. So the initial vector is this one. Take the origin. This is R initial. And this is R final. So it's very obvious it is A by 2 K cap, right? That's directly we can write the answer, right? Are you guys able to understand the delta part or shall I
Yes, sir.
explain this? Clear?
Yes,
Yes.
sir.
So delta is A by 2 K cap. Now what we have to do next? Take the dot. So F dot delta. So only K cap will survive, all will vanish. So it's F A by 2 root 3. That's it. Answer. This is unit. I think how much you got, Siddhant?
Sir, actually, I made a mistake. Instead of root 3, I wrote just 3.
Ah,
Yes, sir.
even such kind of mistake is also there. So not very easy. I mean, yeah, I can understand. It's really difficult. Okay, so all right, with this question, we can end the work calculation because see, there is no end to it, and there is something called work done by variable force. So that is part of your work energy power chapter. Don't worry, work done by variable force. We can't use this formula if the force is variable. So we have something called integration method and all, which you will learn later on. Don't worry. And see the symbol for integration, we write F dot dr vector. So of course these things will come in chapter pertaining to work. As of now, you can just ignore. If you don't understand, it's totally okay. The other definition which we should be aware of is called power. And particularly we talk about the instantaneous power. Instant. So from your high school, do you know what is power? Power is
Rate
the
of change.
rate of doing work, right? Rate of doing work is called power. So let's say if you have maybe 5 pieces of bread, and let's say if I give 5 pieces to everyone, all of you. So the first person, let's say one of you consume all the 5 pieces in 5 minutes. The other one consumes in 4 minutes. Someone consumes in 3 minutes. Someone in 2 minutes. So the amount of bread which you have consumed is same, but the time taken is different. So who is having the maximum power of consumption? The one who takes the maximum time or minimum time?
Minimum time.
Minimum time. So of course the energy, the bread is like something energy, and the time is something you take to consume it, dissipate it, store it, and so on. So the power is defined in physics as F dot V, where V is called velocity vector. So the force and dot of velocity gives the power. If power supplied is zero, which implies F dot V must be zero, which implies that force must be perpendicular to velocity. And this generally happens in case of magnetism. So when a charged particle moves in magnetic field, the magnetic field never imparts any power or any does any work, and so the particle moves with constant speed without changing the energy. And of course these phenomena can be seen on earth. We have the something called aurora borealis and aurora australis, the northern lights and southern lights, and these lights are due to the motion of charged particle in the presence of earth's magnetic field. Anyway, so that's a different story altogether. We'll come to that. Now these are two things which you will very often see in vector chapter, especially if you are studying in a coaching, you need to solve or answer these questions. But the dot product application in physics is tremendous. So I'll show you the various formula of dot product in physics. So let's see some other applications. So the work, and this is not the only thing which we study. So we have something called flux. So influx is everywhere in physics. And flux we can write for electric field E dot area vector. In magnetism we write E dot B dot A vector. So I'll add the actual form. Anyway, we will not mention much. So we write E dot dA integration, then magnetic flux we write B dot dA integration. We have gravitational flux we write G dot dA integration. We have velocity flux we write V dot dA integration. And then we have many more flux. There are many more actually. So we have luminous flux. We have a lot variety flux. Just a moment. So we also have something called potential difference. And how we write this potential difference? We write minus E dot dl, which is again displacement only. And E is called electric field. B is called magnetic field. This is called magnetic flux. Gravitational. Gravitational. Velocity flux. Electric flux, and so on. We have potential difference relation. Okay. We have something called rotational work. Rotational work. So there is something called tau dot d theta. We call torque actually. Anyway, don't try to understand any of these. I'm just writing for the sake of writing, nothing else. So dot product in physics will appear in many places. So we have something called magnetic dipole moment. So magnetic dipole energy, actually magnetic dipole energy minus Pm dot B electric dipole energy minus P dot E. There are a variety of things. Okay. So in physics, the dot will appear in various other chapters. We may have some more complex formulas. This is just like awareness. You should know these things we are going to use in chapters. And most of the dot product we will use in class 12th, except in 11th we have work chapter, then most of the chapters are in 12th. Okay. So now I think we should start the geometrical meaning of dot product. Let's start. Geometrical meaning of dot product. So let's say we have two vectors A and B again. So A and B are like the permanent vectors to teach this chapter. So let me make it bigger. So we have two vectors A and B. and they are inclined to each other at angle theta. Okay. So what you can do is you can drop a perpendicular from the tip of the vector. So first of all, we have joined them tail to tail, and then what we do next is we drop a perpendicular from the tip of the vector to the other vector. So if you look at the first triangle in which the the altitude is vertical, let's name it O, B, C, D. So in triangle OBC, can you tell me what is OC value? Can you tell me what is OC?
OP cos theta.
OC is OB cos theta. And what is OB in length? Which is the length of the
B vector.
B vector. So OC we can write as B cos theta. Am I right? All right. In triangle OAD, what is OD, guys? What is OD? OD is
A cos
Oh,
theta.
A cos theta.
A cos theta. Very good. So OC is B cos theta and OD is A cos theta. That's really interesting. So these lengths are called projection or shadow. What we call projection or shadow. How to think like this? Why I'm saying shadow or projections? Imagine OA vector is acting as a screen. Okay, and the light ray is coming from the top. So light ray is coming like this. How light ray is coming? Perpendicular to the A vector. In the path of this A vector, the B is like obstacle. Correct? So this light ray will fall on the vector OA except for the part which is obstructed by the OB. Yes or no? Can you
Yes,
see
sir.
that? So there is a part which is on which the light ray will not arrive, right? Which part? OC part. So do you realize that this part will be like having the shadow? No light ray.
Yes, sir.
So shadow depends on length of the vector, angle of the angle between the vector, or only length, or both. So shadow depends on how much is the length and what is the angle. Yes or no? You can see OC depends on what? B as well as theta. Correct? So if I make the theta smaller, the shadow length will grow or shrink. Can you imagine, visualize something? If theta will decrease, my shadow will
Grow.
grow. So when my shadow will be maximum?
When
When theta is 0.
Exactly, when vectors are parallel, right? So when vectors are parallel, the shadow will be maximum. Yes or no?
Yes, sir.
And when my shadow will be nothing, zero, no shadow, no projection.
Perpendicular.
Perpendicular. Very good. So if it is exactly 90-degree, the shadow will be like a dot. So we can say there is no shadow. So the idea of projection we express in terms of dot. So we'll come to that. What is the idea of shadow? So shadow or projection is nothing but the component, the effect. Okay, so we'll come to that. What is this effect is trying to convey physically. Okay. Now imagine the other situation. I have OB is my screen. So how the light ray should come? Like this, normal to the screen. So bring the light ray. Okay, this is too much. Okay, okay, I should control my emotion. Okay. So let's say the light ray is coming like this. Okay, let me just measure it. So if the light ray is coming like this, can you see the shadow now? So what is the length of shadow now? Tell me, guys. The length of shadow is OD.
Yes, sir.
So OD is called projection of A onto vector B. What is OD? Projection of A onto vector B. So what is OC? Tell me, guys, what is OC?
Projection of vector B on vector A.
Correct. Projection of B vector onto A vector. The shadow part. Projection is shadow. And the shadow is also like a component, the effect. And what is OD now? Projection of A onto B vector. Is this clear? Yes or no?
Yeah.
Tell me, guys. So OC and OD are called projection. And what is OC vector? It is called projection vector of B onto A. What is OD vector? Projection vector of A onto. So projection is only the magnitude part and projection vector is the magnitude and direction part of both. So we have to express these answers accordingly later on. Now coming back to the A dot B definition. What was the definition of A dot B, if you remember?
AB cos theta.
And so we can write this as A multiplied by B cos theta. Or we can write this as B multiplied by A cos theta. Yes or no? So what is this? What we are trying to write here? We are trying to write that A dot B is the product of A and projection of B onto A. Do you realize this?
Yes.
And it is trying to convey some information that these are parallel effects. I am trying to understand what is the product of first vector and the effect of second onto the first vector, or vice versa. And what is A cos theta? Projection of A vector onto B vector. Am I right?
Yes, sir.
And therefore, if I want to know the value of projection, so projection of B onto A will be how much? So I can use this relation. And can I write this as A dot B divided by A? Can I write yes or no? From the first equation, can we write like this? Yes or no? Okay, I'm not getting. So this we can express like this, no?
Yes, sir.
Tell me, guys, can we write like this? Yes or no?
Yes.
And this we can rearrange into a nice form: B dot A vector by mod of A cap. So B dot A cap. So what is the meaning of B dot A cap? So the shadow on which vector? A cap is the screen, correct? And B is the vector. So what is B dot A cap means? The shadow of B vector onto A vector. So to find the shadow of a vector onto another vector, what we do? We take the vector and we multiply, or we take the dot with unit vector of the screen, the direction in which you want the shadow. Are you getting this point?
Yes, sir.
So to find the shadow of B onto A, you take the dot of B with unit vector of A. Logical. So what you will do for the reverse process?
A vector dot B cap.
Correct. So what is B cap? The screen or the object?
As a screen.
Screen, yeah. So the unit vector always represents the desirable direction in which the shadow is demanded. So we demand shadow in a given direction. We demand projection in a given direction. And projection is like an effect, like a shadow, like a component. There are multiple ways to interpret and understand. Okay. And that's very, very important. In mathematics, you need to understand this concept very, very well. And the entire idea of shadow or projection is the basis of the advanced studies of artificial intelligence and machine learning. The basic math on which the concept of machine learning relies is the projection. In fact, we have something called principal component analysis, which is the integral part of machine learning technique. And these are the mathematical algorithms which we interpret or implement in some more advanced mathematical ways. Idea remains the same. So if you understand the vector here, you will have no problem in understanding entire machine learning in higher studies when you're doing the BTech in the second, third year, when you will start learning maybe artificial intelligence or machine learning, you will have by ease with which you can understand. So vector is important in many ways. It is not only meant for learning physics and solving some easy questions, having far-reaching consequence, and of course you will learn a lot about it. So what we are learning is maybe one drop in the ocean about vector algebra, the tiniest part. Okay, so imagine if the tiniest part is taking 10 lectures, so the biggest part will take how many lectures? Okay, so next part is projection of what we got? B of A onto B. So by definition, you can see so projection of A onto B is how much? A dot B by B. A dot, and this is logical. This comes out to be A dot B upon B, which means A dot B cap. So projection of A onto B is A dot B cap, the shadow, the projection. Okay. So now it's very easy to find the projection vector. So what is OC vector, guys? So can we write OC vector equals to OC into direction? And what is the direction of OC? Can you see here? Direction of OC is same as A vector.
Yes, sir.
So direction of OC is same as A vector. So where can we write A cap? Simple enough. You multiply the vector with the direction, it becomes a vector quantity. Yes or no?
Yes, sir.
So basically, direction of what is this? Direction of OC is same as A vector. So can we write OC upon OC modulus is A upon A modulus? The same old definition. If you may remember the thing we did earlier. When two vectors are parallel, how we write? We write their unit vectors equal. Yes or no?
Yes.
So can we write OC is OC into A cap? That's a subtle way of writing. There is only one definition which we use very frequently, and that is when two vectors are parallel, their unit vectors must be equal. And we use that idea again and again to express vertical and multiple answers. And OC we got. OC is projection value. What was OC, if you remember? B dot A cap, if you remember. OC was the projection of B onto A. You can check. 1 second. OC is the projection of B onto A. Yes or no?
Yes.
So does this make sense? OC is B dot A into A cap. So the projection vector, how we write? B dot A cap is a number into vector. See, the left hand side in bracket is a number. It is no longer a vector, it's a pure number. So it may be confusing that are we writing vector, vector? No, it's scalar and vector. So this is the scalar product, yes or no?
Yes, sir.
So it is like you are trying to scale the A cap by a value B dot A cap. So this is the scaling function. You are scaling it. You are trying to shrink or extend, expand or contract based on the value of B dot A cap. Anyway, so this we can rewrite in some expanded form as B dot A upon A and A upon A, which we can finally express as A dot B upon mod of A whole square into A vector. This is a really bad way of writing, but you can write like this. So I really want you guys to do me a favor. Can you please write the OD vector for me? A small help I'm requesting. So no one is interested in helping their teacher.
So doing.
Thanks. So
Can you show
find the
the
OD
previous
vector.
slides?
Yeah, you can see the previous slide, not an issue.
So may I?
Yes, please tell me.
So OD will be B dot A
B dot A.
whole divided by mod B whole square
Very good.
into B vector.
Correct. That's the right answer. So OD vector is OD into B cap. Very simple. And OD was A dot B cap into B cap. You have to learn to, you know, how to write this without looking at the diagram. Mentally, you have to imagine that, okay, this will go the projection and projection into direction. So mentally think about the projection and then the direction. You will get the answer. A dot B cap into B cap, is the answer correct?
Yes, sir.
Yes, sir.
Okay. So anybody who is finding it too difficult, needs some more explanation, or are happy with the explanation? Rugved, Prashansa, you are saying nothing. You can tell me.
Yes, sir. I'm happy with the expansion.
Prashansa, having a network issue. You got the answer? How it is being done?
Yes, sir, I got it now.
Or you missed something like you had?
Sir, I missed the main part when you were explaining the projection part.
Oh my God. Okay, anyway, so you can watch the video. I'll share the
Yeah,
video today.
sir, I'll look at the recording.
Yeah. Okay. Okay, so now time has come to solve some numerical. But no, one more difficult part. I have to do the difficult part. So sometimes we have something called orthogonal projection. So this is called the projection along the vector. So let's say if we have two vectors again, if I draw something like this. So if this is the vector A, and if this is the vector B, so OC is called the projection of B onto A. At the same time, if you draw a perpendicular like this, the CB is called projection of B perpendicular to A vector. That's very interesting. So what is CB here? Okay. What is CB here? Projection of B perpendicular to A vector. So it is not along, it is rather perpendicular. The shadow on a vertical wall on the other side. And it is easy to find because we can use the triangle law, which says that OC plus CB must be equals to OB. Yes or no? OC plus CB equals to OB. Can we write like this? So the projection along and perpendicular will add up to the actual vector. Do you realize this? So that's why we resolve the vectors into two mutually perpendicular components, because if you add those two values, what we will get is the actual vector. So CB, we can directly get the CB vector, that is the projection vector. So what is the CB vector directly? OB minus OC. And OB is B vector. And we have learned how to find OC. OC is the projection of B onto A, correct? What was OC, guys? Projection of B onto A, yes or no?
yes.
Yes, sir.
So B dot A cap into A cap. Can we write like this?
Yes, sir.
Okay, so you can see the CV turns out to be B minus B dot A cap into A cap, and you can take the CV dot CV. It's very interesting. I'll just show you something. So B dot B is B square minus. Oh, by the way, what is B dot A cap? It is B cos theta, right? What is B dot A cap?
B cos theta.
Mod of B, mod of A cap into cos theta, and mod of A cap is 1 because it's a unit vector, so it is B cos theta. So basically, it is B cos theta is a number, and okay, anyway. So first of all, we'll write B dot B B square minus twice of B dot A, which is number outside, into B dot A cap will come again, and then you will get minus B dot A cap whole square into A dot A dot, which is 1 anyway, plus. This will be B square minus B dot A cap whole square plus B dot A cap whole square, and A dot A cap is 1 because it's a unit vector. So this will become B square minus B dot A cap whole square, which is basically B square minus B cos theta whole square, which is B square 1 minus cos square theta, which is B squared sin square theta. And so the CV mod is actually B sin theta, which we know from trigo. That's the answer, right?
Yeah.
So we know this answer anyway, but this is the difficult way to get the simple answer. Okay. So if you play with vector, these things will appear good to you. If you hate vector, then anyway, you can curse me also for writing all these things. Okay, so in mathematics, you have to solve vector equations. It means you have to play with vectors, and you will realize that most of the questions demands a vector manipulation. You have to manipulate vector with vector idea by taking dot, by taking cross, and doing something like that. So to find the perpendicular projection, the rule is simple. You find the parallel projection and subtract from the actual vector, you will get directly the perpendicular projection vector. Okay, so after this, we can solve some numericals. So we are done with the dot. So let's do one problem. And one problem is sufficient. Now, when I draw normal vectors, it's easy. But if I draw some very complex vector, let's say if you go back to the cube problem, because that's very interesting and very, very important. I mean, this will be the most difficult questions can you solve with this idea. So right now we are getting this idea through vector. Later on we can get it by common sense, trigonometry and something. Imagine this is a cube of some side, and we have a diagonal. Okay, this is the diagonal. Let's find O. So I have simple question. Find the projection of OA along OB direction. Find the projection of OA along OB direction. That's it. So what is the shadow of OA along OB? Can you see the shadow length? What I'm asking? Find the projection of OA along OB.
Shadow length is A.
Yeah, A itself is the answer. It means no need to solve actually. There's no need to solve. But what is interesting is that if I want to know the angle between these two vectors, I can put the use of dot product also. Okay. So dot product gives what? What is the meaning of dot product of OA and OB? So OA dot OB is like OA multiplied by projection of what is OB? Projection of, tell me guys.
OA onto OB.
OA onto OB. So OA is lengthwise. We know what is OA length. OA is A. What is OB length? We know the answer.
So OA is √3A.
Oh, my bad. Yeah, just I reversed. So OA is √3A. What is OB length?
A.
So into cos theta or cos alpha, I will find the cos. Okay, let me just small change. I don't want this to be okay. Anyway, doesn't matter. Leave it. Yeah, fine. Cos alpha. On the right hand side, the OA is how much? The OA OB cos theta. Oh, my bad. And this is okay. I'll just change it. Change this. We know the projection of OA onto OB, right? So this we can write as OA OB cos theta. OA OB cos theta. So we can write as OB into OA cos theta. Correct?
Yes.
And what is OA cos theta? The projection of OA onto OB. So that's why, because we know this answer. So this is OB into projection of what? OA vector onto OB vector. And now we can put the definition. OA, which is √3A, OB, which is A, cos alpha is OB, which is A, and this is also A. Correct?
Yeah.
So you can see what we cancel out.
Is
√3 cos alpha is 1. So cos alpha is 1 by. Now this is very difficult to find. Not difficult, it's very easy to find using basic trig also. For that, you have to draw a separate triangle. It doesn't look like a right angle, right? But it is a right angle. And so cos alpha is how much? Base upon hypotenuse, which you can see clearly. So cos alpha is how much? Base is A, and what is the hypotenuse? √3A. So anyway, we got the answer. And the third method, if you remember, the direction cosines, which we have described already. Choose the XYZ. And because the diagonal is symmetrical in case of cube, so the angle between any body diagonal and edge will be same. So all angles will be alpha. You cannot visualize as equal, but they are equal. You have to believe that they are equal. Because we are drawing 3-dimensional picture on a 2-dimensional plane. So the image will get distorted. You cannot see the reality. Okay. So anyway, let's do some other problem. So projection is shadow. Huh? So let's say we have a vector A having value 2i cap plus 3j minus k cap and b equals to I plus j. I don't know how it looks like. So it is difficult to understand their actual orientation in space. So here the definition will help, because when you don't see, you have to use the mathematics. So mathematics is a way to deal with abstraction. Of course, if you can have a proper visualization, things will be easier. But even in the absence of visualization, the mathematical formulas are actually meant to work in a fashion which doesn't need any physical appearance. You can do it mathematically, purely mathematically. So how many questions I can ask here? First, find the projection of B vector B onto A, projection of A onto B, projection vector of B onto A, projection vector of A onto B, projection vector of A on onto onto B with a small change. So we can call this as perpendicular projection. Okay, so let me just make it a vector. So these are the questions you can solve. Okay. So what I will suggest is that you find A cap and B cap separately, and then keep on substituting the value to get the answer. So tell me these answers one by one.
So the first one, can I say the answer?
Yeah. Okay.
4
So-
upon root 14.
So selecting number one. That's 6 question. So the answer for the one is
4 upon root 14.
correct. I think it should be correct. So what is a cap? 2i3j minus k upon 491. And b cap is by root 3. And what you're writing is b onto a b dot a cap. B dot a cap. Yeah, that's fine. So it's 2, 3, 5 minus. Yeah, that's correct. So question number 2.
So 4 by root
English.
3.
How much?
4 by root 3.
Yeah. Now this time it will be a dot b cap, right? So which is of course 4 by root 3. Correct. So the third part is now it's easy. Projection vector of b onto a. So b onto a is b dot a cap, which we got the answer already. 4 by root 14 into a cap, which is on anyway known to us. So you can take some time to realize this. So anyone getting this answer? Question number 3.
Yes, sir.
2 by 7 into this answer. And so you can do 4, 5, and for perpendicular projection, what we do? We find the parallel projection which we have already, and we separate from the A vector, right? Anyway, just finish this.
So for perpendicular, I didn't understand what.
Every vector will have two projections, one along the vector, another perpendicular vector.
Yes, sir.
If we have a vector A, and let's say this is any line, no need to say this is B or whatever. So every vector we can have two components, one along another perpendicular like this. So this you got the projection vector. This is the A cos theta. So how to find A sin theta? That's the question. And that too in vector form. If you name it OAB, so we know
Got
how
it,
to
sir.
find OB vector. So we can find BA vector. The triangle also says that OB plus BA will be A vector. So what is the BA vector, guys? And you know how to get OB vector, which is the projection of A onto B. That's it. And then you can expand and do something like that.
for the fifth question, is the answer A cap?
Uh,
Which is
A minus the answer which we got in. Sorry. A minus 4. No, I mean something else with them, no? Not something. I haven't checked. You can check. So the fifth question will be the answer this one. What is A cap? It is A dot B. What is A dot B by the way? 4 upon B square, which is 3.
root 3.
B square is 3 now because into B cap. So okay. 3 to the 6 minus 4. 9 minus 4 minus 3 minus. This is the answer. 2y plus 5j minus 7k by 3.
Yes, sir. Understood.
Okay. All right. And the last is again easy. You can do the last part also. And please, if you are not, I mean, if you have not understood much here, make sure that you practice enough to understand. So if it is not coming to your mind at one go, don't worry about it. Try at least twice or thrice. And if you're not getting it, you must ask in the next lecture. So maybe I will explain once again. Only if you have put the enough effort, you can ask. So the projection is a very interesting concept and a very powerful tool in many cases in mathematics. Before I wrap up today's lecture, let me show you something simple and interesting fact about projection. So the resolution of vector which we have already studied. Look at that part once again. So imagine this is any vector A. So when you find the x component, what you are trying to find, you find the projection of A along x-axis, isn't it? So what is the AX value? AX is the projection of vector A along x-axis, yes or no? Tell me guys.
Yes.
So can we write this as A dot I cap? Simple.
Yeah.
So actually when you multiply A with I cap, you get the X component directly. And to find the Y component, what we should write? A dot. So similarly in 3 dimension, I can also extend this to idea. A dot. So every vector A we can write as A dot I cap into I cap, A dot J cap into J cap, and A dot A cap into, and that is why it looks like AX I cap. Interesting. So the component is basically projection, and projection is like a shadow. So when you will not get any component, when it is perpendicular. So if a vector is along the x-axis, can we get its y component? Tell me, guys. A vector along the x cannot have the y component, true or false? So let's say if two vectors are mutually perpendicular, A and B, what is the projection of A on B?
That would be AB cos 90 and that would be 0.
Yeah, so there is no projection. You can see there is no shadow. If the light ray will come on A, B will cast nothing. If light ray will come on B, A will cast nothing. It means these two are mutually perpendicular and will never cast any shadow. And that is why we can say, okay, these are having no projection. And projection means what? Having a projection gives you the idea that, okay, they can be related. And having no projections, they cannot be related. It means they are independent. So two vectors which are mutually perpendicular are also mutually independent. That's the most important concept in vectors and also in machine learning. Yes. So vectors which are orthogonal are independent. So in 2 or 3 dimensions we call perpendicular. But in higher studies, we don't use the word perpendicular, we use the word orthogonal. Orthogonal is a generalized way of saying perpendicular, but the word orthogonal is true in any dimension. So for you, orthogonal is a fancy word for perpendicular. Okay. So in mathematics, you will study the orthogonal trajectory, orthogonal family of curves, and so on. Anyway. So we'll see some glimpse of mathematics also, because the calculus is some part which I will teach, and you will enjoy this. That's very interesting. I'll show you the physical meaning of mathematics, how mathematics actually deal with our day-to-day life activities, and why we are right in a way, the way we write. The last topic which is left is called cross product, which I will take a separate topic. So your next lecture will be the last lecture for vectors, and after that we'll go to the world of mathematics. But I do want to stop the physics also. So what I have planned, that I will take one lecture maths and one lecture kinematics. Okay, so that we should also link with kinematics and mathematics. And if maths comes early, before, if you need some mathematical ideas in kinematics which you are not aware of, I will first teach mathematics for that part only and will proceed. So I don't want to keep only maths lecture, because that will become too boring. So one lecture I'll keep as physics and one lecture as mathematics. So I will start parallelly kinematics and mathematics, or maybe I can go on starting the laws of motion also, because that will not demand any maths. So till then we are finishing the maths, we can also finish the laws of motion. So both possibilities are there, and depending on what you have learned so far in mathematics, I will take my next decision. So tell me what you have studied in maths so far.
So we are doing trigonometry right now.
You
So
know
like we have
maths.
done wavy curve method, modulus
Okay,
inequalities.
okay. So you learned the equation also, quadratic equation, polynomial equation.
So
Correct.
quadratic we haven't done, but linear inequations,
Of course, the wavy curve
logarithms.
start from, the wavy curve method start from quadratic to any higher polynomial.
Yes.
All right, not an issue. And Professor, you have studied something more, I think. What you have covered so far? Calculus also?
So calculus and trigonometry. Calculus we have done in physics, but
Yeah,
not in
yeah, that's fine. And Rugved, I think you have also covered more than that. So what you have covered so far in maths?
Logarithm and linear inequations.
And in like physics, maths, like mathematical tools, have you covered something?
Yes, differentiation, integration, all that.
Oh, all that you have covered. That's great. So, I mean, do you really need the differentiation and integration?
I don't understand.
Now, do you need the revision of integration and differentiation, or you're okay without it, or you want it definitely?
Sir, you can teach.
No, I can teach, I know, but do you need it? That's
Yes, yes.
okay, fine. No, anyway, even if you have said no, I will take the lecture because I want to teach maths for some very interesting reason, which you will realize later on. Okay. So in maths, in physics, the maths is taken as abstraction. So when you learn maths in mathematics, you only see the abstraction, only formula, formula, formula. And when you learn physics, I mean mathematics in physics, then I'll give you the physical interpretation of every formula. For example, what do you mean by what is the physical significance of linear equation? Anybody? What is the physical significance of linear equation?
We kind of take into account all the possibilities for a certain scenario.
Like what? Can you elaborate a bit more?
Like probably price over of a product over a year. I mean across different months.
Okay, okay. I think you have seen the first lecture of vectors, right?
No, sir, I haven't yet. I'm yet to watch.
So the idea is the linear equation represents dependency, the proportional relationship between two values. So that's how we came across the linear equation. The quadratic is of course not proportional relation, so it will have some more ideas. The cubic will have some other physical meaning of it. The parabola will have other meaning. Ellipse will have different meaning. So all mathematical expression will have some physical significance, and we'll see through the lens of physics and math both. All right, guys. So see you in the next lecture on Friday. And what you can do now, you can do almost all questions of SC Verma. You can do all questions from the sheet which I have shared, except cross product. I want everything to be finished. And then you have the last topic. You must have seen the vector objective practice. Have you seen that notes?
Yes,
Vector
sir.
objective practice. That's very interesting and challenging questions. You may not have the answers there. Options are there, but answers are not there. So you can try those questions. We'll discuss because many answers are incorrect also. So don't see the answer. You just solve, and any question which you find difficult, we'll discuss there. But wait for that chapter. Don't solve as of now. Once we finish the cross, you can solve because that is a mixed bag of problems. Okay, guys. Good night and take care. And finish as much as possible from the sheet and everything else.
Thank you, sir. Good night.
So can you
Bye, sir.
please
Thank you, sir.
do a recording?
Yeah, I'll share after 10 minutes because it takes some time to pre-process.
Okay,
And
sir.
once the processing is done, I'll share. Don't worry, I'll share for today only.
Okay, sir. Thank you.
Okay, good night.
Good night, sir.
Bye, sir. Thank you.